In this video, we want to go over the review for the quiz for calculus. So what we're looking at is we're looking at limits. So anytime you look at a limit, if you remember, the first thing you want to do is you want to plug this number into the limit. So if we plug in -2 plus 5 over -2 plus 4 to see what you get. And if you get an answer, such as 3/2, that is your answer. If you plug a number in here, if we plug in 3 here, we are going to get 0 over 0. And so if we have 0 over 0, that means more work. So in this case, we can factor the top into x minus 3, x minus 5. That allows us to then cancel the x minus 3. So we would have the limit as x approaches 3 from the right of x minus 5, which when you substitute 3 in, you get -2. So you see in this case, the fact that it's from the right does not matter. Okay. So the next one. We have the limit as x approaches 3 from the left. So if we plug in 3 into the top, we get 2. Plug in 3 into the bottom, we get 0. So now we have a number over 0. Since we're approaching from the left, if we want to think here is 3, if I approach from the left, I am putting in a number less than 3, such as 2.9 or 2. So if I put a 2 in there, 2 minus 3 is a -1. So this 0 here is approaching 0 as a negative, really, really small number. So I have a positive 2 on the top. So my limit goes to -infinity. I have the limit as x approaches 9 of the square root of x minus 3 over x minus 9. If I plug 9 in, I will get 0 over 0. What we have to do is factor the bottom into the square root of x minus 3 and the square root of x plus 3. Once again, we would not necessarily ever really factor that way other than it matches the top. So now we can cancel. And I have the limit as x approaches 9 of 1 over the square root of x plus 3. Now when I substitute in 9, that gives me a 3, so I get 1/6. The limit of sine of x minus 3 over x as x approaches 0 from the right. So we want to split this up because we know sine of x over x and then minus 3 over x. Let me change colors here. We know that this is equal to 1. This part here, 3, is going to end up being 3 over 0. It's a positive 0, which we know is going to go to infinity. So I'm going to end up with 1 minus infinity, which is just going to be minus infinity. Here the limit as x approaches -1, x squared minus 5x plus 6. So if I substitute 1 in, the top goes to 2, bottom goes to 0. But I am approaching from the left. So I am putting a number in less than 1. So a number less than 1 minus 1 gives me a -0. So this goes to -infinity. The limit as x goes to 0 of 1 minus the square root of x plus 1 over x. Once again, if I plug 0 in, I get 0 over 0. So in this case, because we have the radical, I'm going to multiply by the conjugate. So I'm going to multiply the top and bottom by the square 1 plus the square root of x plus 1. So in the numerator, I'm multiplying by the conjugates. So my first term is 1 minus my last term, which is the square root of x plus 1 times the square root of x plus 1, is just x plus 1. Remember, I don't need to FOIL my inside and out, my outside and inside terms because they will cancel. So now we get to here. And if I cancel, you will see these ones cancel. I have negative x over x. The x's cancel, and I'm left with a negative 1 on the top. So when I substitute in 0, I have negative 1 over 1 plus the square root of x plus 1. And when I substitute in 0, this is a negative 1 over 0, gives me a 2. The next one, as I put in a 2, the top gives me a negative 2, the bottom gives me a 0. So as I'm approaching from the left, I have to determine, is the bottom a positive or negative 0? Well, as if I factor the bottom, this gives me x minus 2 squared, which tells me as I'm approaching, no matter which way I'm coming, from the left or the right, this is going to be a positive 0 because it's the bottom squared. So this limit is negative infinity. Next, for any epsilon, find delta. So we want to always start this with the f of x minus L is less than epsilon. So in this case, this would be x squared minus 1 minus 15 is less than epsilon. And because this is x approaches 4, we eventually want to end up with x minus 4. So that's where we're going. So we get x squared minus 16, which this factors into x plus 4, x minus 4. And we know as x gets close to 4, x plus 4 gets close to 8. So I'm going to divide by that 8, but because I'm dividing, I have to make it go 1 bigger. So I'm going to divide by 9. So my delta is epsilon over 9. So onto the back of our worksheet, using the graph, we want the limit as you approach 1 from the right. So 1 from the right is 3. We want the value of f of 1, which is where the dot is. That's 1. We want the limit at negative 1 from the left, which is 1. We have the limit of 2 from the right, which is negative infinity. The limit at 2, since both from the left and the right are going to the same place, by theorem Bob, it is going to negative infinity. The functional value at negative 1 is the value here, which is 1. The limit at 1, from the left is going to 3 and the right is going to 3, so the limit at 1 is 3. And the limit at negative 1, the left is going to 1, the right is going to 2, so the limit here does not exist by theorem Bob because the left and the right are different. And finally, using our squeeze theorem, if we have G and H, and we know G and H is all, F is always in the middle, what is the limit as x approaches 4 of f of x? So we want to find what is G of 4. If we put G of 4, we get negative 16 plus 12 plus 4, which is 0. H of 4 is negative 20 plus 20, which is 0. So if G goes to 0 and H goes to 0, and f of x is always in between them, f of x also must go to 0. Now, we also have a take-home review sheet. So let's kind of talk about that also. So first off, we have our limit here, and if we plug in -2, we will get 0 over 0, because the top can factor into x plus 2, x plus 5. So we cancel the x plus 2, we substitute in -2, and we get 3. If we substitute 2 in here, we get -10 over 0. But we are approaching 2 from the right, so we put a number in bigger than 2, let's say 3. And 2 minus 3 is negative, so that tells us from the right it's negative. But we have a negative over a negative, which tells us this goes to positive infinity. We have the limit as x approaches 1 of 7x plus 10 over x minus 1. If we put that 1 in, we get 17 over 0. But because our limit here is not from the right or from the left, this limit does not exist, because from one way it's positive and from one way it's negative. The next one here, we have 3. When we plug 3 in, 3 squared plus 1 is 10. On the denominator, it's 0, but we're putting in a number to the left of 3. We're approaching from the left, such as 2. That gives us a -0, so that is negative infinity. We have another conjugate one, so we need to multiply by the square root of x plus 1 plus 1, square root of x plus 1 plus 1. When you FOIL the top, the bottom, nothing cancels, so we just have our two terms. On the top, our first becomes just x plus 1. Our outside and inside terms cancel, and our last is -1. So the ones cancel. I'm left with x here and x on the top. They cancel. So then when I substitute in 0, 0 here gives me the square root of 1, which is 1. 1 plus 1. And I have 2. Over here, when I plug in 0, it doesn't work. So I need to get common denominators. So if I get common denominators, this factors into m times m plus 1. So I'm going to multiply by m plus 1 over here. So that gives me m plus 1 minus 1 on the top, m times m plus 1 on the bottom. And if we just do some algebra here, we can cancel. The ones cancel, is very similar to the last one. Then all we're left with is m on the top and bottom, and that cancels. We plug in 0, and we get 1 over 1, which is 1. For any epsilon, find delta. So we start with f of x minus L is less than epsilon. So this is 2x minus 6. Now, remember, what are we trying to get to? We're trying to get down here to x plus 3. We know we're trying to get that because we have a -3 here. So if I factor out a -2, then I have x plus 3 here. That -2 inside the absolute value, remember, you can never have a delta that's negative. So when I divide that -2 out, it just becomes a +2 because it's inside the absolute value. So my delta is epsilon over 2. We have our squeeze theorem or sandwich theorem. We want to find what's the limit as x approaches 3 of f of x. So I want to find what is g of 3. If I plug 3 into g, I get -21. If I plug 3 into h, I get -21. Therefore, f of x is -21. And the last one's a piecewise function. If I want to find the limit of -1 from the left, that is less than -1, so I use the top, which would just be -1 plus 3, which is 2. If I want the limit at -1, I got to consider the left and the right. So if I want to find at -1 from the right, that is going to be this formula. So that is going to be -1, excuse me a second. I have to consider the limit of -1 from the right. And from the right, it goes into this equation, which would be 1 plus 1, which is 2. Now, the limit from the right and the limit from the left are the same, so the limit at -1 is also equal to 2. The functional value at -1, though, is equal to 7. If I want to find the limit at 3 from the right, that is greater than 3. So I plug that into here. So that is 3 minus 2, which is 1. If I want to find the limit at 3, I need to consider the left. So the limit as I approach 3 from the left is going to be using this formula here, x squared, which would be 3 squared plus 1, which is 10. The left from the right are not the same, so by theorem Bob, this does not exist. And finally, what is f of 3? That is just plugging in where it is equal to 3, which is 10. So there is a video over the review that is the take-home review and the review that was for in class.